Hello and Assalamualaikum everyone. Thank you for joining us today. My name is Muhammad Nabil Hakim bin Mat Isyamuddin and I'm a project manager of XYZ company. So today I'm excited to share about our new project, which is rooftop photovoltaic system at Faculty of Electrical and Electronic Engineering FKE buildings, sponsored by UTASHAMS. So without further ado, let's get started. This is our project summary on rooftop photovoltaic system at Faculty of Electrical and Electronic Engineering FKEE. Our organization prioritizes client satisfaction by providing the best service, and this project aligns perfectly with that mission. Approved on June 9, 2024, this initiative aims to significantly reduce the FKEE building's monthly electricity bills by installing a rooftop photovoltaic system. The primary problem we are addressing is the high electricity costs incurred by the FKE buildings, which relies heavily on power for lighting, air conditioning, CCTV and various electronic equipment. Additionally, the current use of non-green energy sources contribute to environmental concerns due to the consumption of finite fossil fuels. By shifting to solar energy, we will reduce greenhouse gas emission and promote the use of clean, renewable energy. Our project goals are clear: to reduce electricity costs at UTASHAM's FKE buildings and to implement a reliable backup power system. This will be achieved by installing an off-grid solar panel system with electrical storage. The main objective is to leverage alternative energy sources to power this building, ensuring a sustainable and cost-effective energy solution. Previous research support the feasibility of this project. The FKEE building's location is ideal for solar energy, receiving 4 to 6 hours of sunlight daily. Malaysia has been burgeoning hub for the solar industry, with significant growth in rooftop solar installation over the past few years. This project will utilize monocrystalline solar panels, known for their high efficiency and durability, ensuring maximum energy output per square foot. For the installation, we will be using high-quality materials and components, including monocrystalline solar panels, rechargeable battery bank for energy storage, charge controller to manage electricity flow, and inverters to convert DC to AC power. The installation process involves several critical steps: initial assessment and planning, design and permitting, procurement, installation, inspection, and ongoing monitoring and maintenance. We will conduct a true site evaluation to determine the best placement for the panels and ensure the structural integrity of the roof. We will then design a system tailored to the building energy needs. Post-installation, the system will undergo a rigorous inspection to ensure compliance with our regulations. Once approved, the system will be interconnected to the grid. A monitoring system will be set up to track performance. Regular maintenance will be scheduled to keep the system operating at peak efficiency. In conclusion, this project not only promises to reduce electricity costs, but also supports UTASHAM's commitment to sustainability and environmental responsibility. By transitioning to solar energy, we are taking a significant step towards a greener future. Thank you for your attention, and I look forward to seeing this successful implementation of this project.
Assalamualaikum warahmatullahi wabarakatuh. So my name is Muhammad Najwan bin Abdul Rahman. My metric number is DE230079. So for my part, presentation is project timeline. For the first is project manager, which is handled by Muhammad Nabil Hakim bin Mat Isyamuddin. Number 2 is Chief Financial Officer, which is Muhammad Mustaqim bin Jamaluddin. For third, marketing manager is handled by Muhammad Shakir bin Muhammad Faiza. So quality manager is handled by me, which is Muhammad Ajwan bin Abdul Rahman. So the last part is procurement manager, which is handled by Muhammad Zikri Haziq bin Musaidi. So the project scope is solar panel plant are the off-grid with energy storage are the kind of solar system used in this project. So this particular system was chosen for the project because it can reduce UTASHAM building long-term electricity cost by using power stored in battery banks to provide free electricity. The Faculty of Electricity and Electronic Building will be host this project after that. So furthermore, the panel will be positioned on the roof of the previously mentioned structure. Next, the Surge Protection Device or SPD will be put alongside the solar panel to shield them from lightning shock and eventually prevent the solar panel from being destroyed by lightning. So, the unprotected PV system are prone to frequent and severe damage, which can lead to expensive repair and replacement expense, outage, and lost revenue. And as a result, when solar panel systems are installed in utilitarian building, in this manner, the power consumed in the building will be high efficiency product with low electricity bill cost. So that's all from me. Thank you.
My name is Muhammad Zikr Razik bin Rosadi and my matrix number is DE230072. My position in this project is as a procurement manager of XYZ company. Okay, today I will present quite project risk, which is solar PV panels are become increasingly common in many homes, apartment buildings, commercial buildings, and industrial structures in the modern world. Although many solar energy firms choose to ignore a few small troubles due to the technologies, many benefits. These flaws must be recognized for their resolutions to succeed. There are two primary types of risks that a solar PV project may encounter during installation. Okay, first, environmental and technological. Okay, concerning the environment, one of the main priorities is protecting biodiversity. Although solar energy is marketed as a green alternative energy source, some drawbacks are rarely considered. Certain dangerous products and materials are utilized in solar photovoltaic systems. This can affect the environment inadvertently when the weather changes, such as during a storm or rain. There are risks connected to PV installation projects. In addition, the sun is crucial to the solar photovoltaic systems. Thus, a couple of overcast and wet days may substantially impact the energy system. Furthermore, solar photovoltaic systems can costly to build initially. Materials wiring, inverters, batteries, and electrical panels are all included in the price. Occasionally, the power produced by photovoltaic panels could be more efficient. Situations where system output is less than anticipated and all or a portion of the PV system is not working occur frequently. When it comes to technical difficulties, equipment malfunctions and outages are frequent issues when operating. Troubleshooting is rather common when installing a PV system. One of the most important abilities of a skilled solar energy professionals is troubleshooting. That's all for project risk. Thank you. Okay, for timeline, first activity is project management, which takes 7 days, which is from 5 May until 13 May. Activities number 2 is design engineer. We take 5 days from 5 May until 9 May. For obtain permits, we take 6 days from 5 May until 12 May. Fourth, for procure materials, we take 5 days, which is from 12 May until 16 May. Next, for installation process, we take 10 days to complete it from 12 May until 23rd May. Next, for install roof attachments, we take 10 days, which is from 12 May until 23rd May. 7. For installation of charge control, we take just 5 days, from 19 May until 23rd May. For commission and inspect 1, we take just 4 days, which is from 14 May until 15 May. And we take from 21 May and 22 May. So for installation of PV modules, we take 5 days, which is from 26 May until 2 June. For installation of battery bank, we take from 26 May until 3rd June, which is 7 days. For commission and inspect, we take just 3 days, which is from 2 June until 4th June. For project complete milestone, we take just 2 days, which is from 5th June and 6th June. Next, for communication plan. So first, kick-off meeting. We did the meeting in interactive presentation just once on the initial of the project, and the goal is to introduce the team and the project, review objectives and management approach. The participant include in this kick-off meeting is the project team, steering committee, and stakeholders. So the in charge is project team leader. Next, task progress update. We just do a short meeting daily, and the goal is to provide daily updates on project progress. And the participant is all project team, and in charge is project manager. Next, for steering committee meeting, we make face-to-face meeting and on every week. And the goal is to discussion on project status, risk and budget. The participant is steering committee and the person in charge is project manager. Next, for status report, the format is on email and frequency is every weekly. So the goal is to report the status of the project including activities, progress, cost and issue. The participant is steering committee stakeholders. The in charge also project manager. For communication in team meeting, the format is face-to-face meeting and conference call. Frequency for this meeting, we just made it if only we needed it. And the goal is to review the project status with the team. The participant is all project team and the in charge also project manager. Next, for stakeholder update, the format we made, the format meeting is on email and we made it monthly. The goal is to provide overall status and relevant project information. The participant is stakeholder and the person in charge is project manager. Last, postmortem meeting, we the format is on meeting with a follow-up document, frequency, just at the end of the project. So the goal is discuss actionable takeaways based on what worked and what didn't. And the participant is all project team and the person in charge is also project manager. So that's all for communication plan. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Shakir bin Faizal. My matrix number is DE230052 and I work as a marketing manager in this project. And now I will present for the calculation, floor plan and schematic diagram of a solar panel.
Now for the calculation, we need to find the energy production, the number of panels needed, and the total space required to install a solar panel. For the energy production of a single panel, we need to define the single panel wattage and times it with average sunlight hours per day. In this case, we take 400 watt single panel wattage and times it with 6 hours. We get 2.4 kilowatt hour per day. To find the number of panels needed, we need to divide the daily energy production with energy production. In this case, the average daily production at FKEE is around 50 kilowatt hour per day, and we will divide it with energy production of a single panel, which is 2.4 kilowatt. We get 21 panels. Once we get the total panels needed, now we can find the total space needed to install all these panels. So to find the total space needed, we need to times the total panels with area per panel, which is 21, times with 2 meters square, which is the area of a single solar panel that has 72 cells. We get around 42 meters square of space needed.
Now for the floor plan, as we all know, FKEE consists of two buildings, which is QA block and QB block. And now we're going to look in depth on how to install and where can we install the solar panel on each of respective buildings rooftop. Lastly, I will present the schematic diagram of a solar panel.
Assalamualaikum and hi, my name is Muhammad Mustaqim Jamaluddin and I am the Chief Financial Officer of XYZ Company, and today I'll be presenting about the overall cost of our project. First, let's look at the manpower cost.
Our team includes a project manager with a monthly salary of RM8,000, a project consultant at RM6,000, a project coordinator at RM3,500, a team leader at RM3,200, and 3 technicians, each earning RM2,300. The total manpower cost is RM28,600. This investment in skilled professional is crucial for the successful execution of the project. Next, we have the material costs. We will be using high quality monocrystalline 400 watt solar panels, which is set price at RM1,903.24. We will be needing 21 sets, totaling RM39,968.04. Additionally, we will acquire 11 sample 48 volt lithium battery banks, priced at RM5,423.10 each, bringing the total to RM59,654.10. Our project will also require 3 charge controllers at a total cost of RM2,643, which each set costs RM881. To convert solar power effectively, we will use 13 inverters, each priced at RM1,583.05, totaling to RM23,519.60. We also have a backup generator Vigorous VXL3000, which costs RM4,114.03. To mount solar panels, we will use 21 mounting system, totaling to RM6,798.12. Finally, we have allocated RM115.25 for a low voltage disconnect.
The overall budget of this project is about RM160,000. This investment is important to successfully execute our solar energy project. That's all from us. Thank you.